All right, it's 1:50 on the dot, so let's get started. Thanks for joining, everyone. Hope you had a chance to grab lunch before this, feel recharged for halfway through the summit. Before we dig in, just a quick forward-looking statement that this presentation is for informational purposes only. Some of the content you see here may be subject to change. And a reminder that at the end of this session, at the end of every session, you'll get a survey. It helps us get your feedback on how you thought this one went. Today we'll be covering cost management foundations, the first 100-day checklist. This will be a foundational course, so we'll cover the basics and work our way up there. My name is Sadhana, Bala. I'm a product manager here at Databricks. I focus on overall cost observability, cost management across product lines.
And I'm Piyush, Singh. I'm also a product manager here at Databricks. I focus on our compute platform, which is where most of your spending happens. So we're going to talk about kind of how to manage costs across many different dimensions today.
Awesome. Well, I probably don't have to convince you about this, why I think about cost management early on. There's a reason you're in this room, but between myself and Piyush, we've talked to hundreds of customers over the years, and we have a good sense of what are the common pitfalls on the early days of using the platform that can really hinder customers from having maximum success on Databricks. The key takeaway here is all the best practices we'll talk about today. If you set these up early on, you'll reap the benefits in the future. So do pay close attention to those. So cost-unaware organizations, what we've seen, again, in our data as we speak with customers, a couple of pain points that they feel early on when they don't get it right from the onset. Often they'll find themselves at risk of exhausting internal budgets earlier than expected. They had no good data-driven way of forecasting their future spend on the platform. Some of them, when it comes to quarterly budget planning, realize there's actually a large monolithic share of IT costs that they can't further allocate down. And that makes it almost impossible to think about chargebacks in the future. And others, when they're sort of given a mandate from the top down to achieve X percentage of savings on their Databricks platform, it's unclear where to start in the first place. There's almost too much fat to trim to begin with. But customers that have figured out their story around cost management on Databricks see the opposite happen. Early on, quarterly planning or whatever your budget securing cadence is, they're able to anticipate and forecast growth, both from individual use cases coming on or new product lines they're adopting. They're able to support the primitives of chargebacks, or if they're building products on Databricks, get a good sense of what are the overall unit economics of products and services they're building on top of the platform. And also, as they're evaluating new technologies, serverless, model serving as example, they're able to confidently adopt and share those technologies among their user base because they're confident they can still stay in budget. So in this session, we will structure our presentations through three pillars here that really are a confluence of effective cost management. From an organizational standpoint, we will talk through how should cost reporting mirror your internal organization's P&L or operating model from the first day. And also how centralized should cost governance be. We'll talk through a couple options we've seen in how customers have adopted their governance model. On a technological standpoint, we will talk through how, if you're in an admin hat, how you actually evaluate different products and technologies to choose from. What are the right use cases that make sense for one technology versus another on the platform? And finally, from a business standpoint, we will talk through tools and processes that you can put in place to both on a continuous basis and on a more periodic basis, keep a pulse on your cost. But first, what are costs on Databricks? Again, we want to run a beginner session here and talk through what the components of cost are. Now, this is not to scale, but if you're looking at your Databricks bill, here's an illustration of the types of cost lines you might be seeing. Likely most of your costs are coming from our sort of traditional compute products, warehouse, clusters, jobs. At a high level, what drives those costs? Well, it's a mix of variables. It's overall the types of instances that you're selecting to create your cluster on. It's the size of your cluster, the number of nodes that might be available for your cluster to scale horizontally, or your warehouse as well. And then finally, it's the total runtime. It's the uptime of your warehouse, your cluster. It's built on a per second basis. So those are the variables that are proportional to your overall compute costs. But as you saw in the keynote today, and as you'll hear more tomorrow, we are launching different types of products on Databricks, and those come with different types of billing models as well. For example, there's another line of products, that's the second category. You're seeing here endpoints, whether it's for model serving, vector search, Databricks apps. The way costs, or the types of costs that are proportional to those types of products are actually more about provision capacity. You want to have a certain level of reliability and availability of these endpoints or these applications. So that's actually more of a mix of variables like processing power, the number of vectors that are available for your vector search endpoint to serve, or pay per token if you're using that form of model serving endpoint. And kind of going down again, these are sort of maybe smaller line items you're seeing on your bill, but just so you're aware of, if you're using any of the default storage product offerings at Databricks, those costs will be proportional to the overall storage costs, as well as the number of API transactions that you might be hitting against those storage buckets. If you're using networking, the cost there will be proportional to the number of gigabytes that are transferred, or if you're using something like private link, even the number of hours that the active endpoint is available. Of course, this is just the Databricks side of the story. What you'll also be paying costs on is directly to your cloud service provider if you're using non-serverless products. There you'll be paying your underlying cloud infrastructure costs. So for example, EC2 networking costs that are actually being provisioned for your clusters to run, as well as storage. But the beauty with serverless, which is what we'll talk about in a second, is it makes cost reporting a lot simpler. The types of costs you will see are really just the big pillars on the left-hand side for you. And one thing we're excited to announce is we've invested heavily in this space in this last year, both for a cost observability standpoint, as well as a cost management standpoint. Spoke with a customer who accurately cited that he's seen more progress in cost management in the last 12 months and the last 4 years. And we have a lot of cool new features that we're excited to announce today and in the future. With that, I'll hand it to Piyush to talk about the organizational considerations here.
Thanks, Sadhana. Okay, so when we start thinking about costs and best practices, what comes to mind? The first thing is making sure you really understand what the organizational boundaries are within Databricks so that you can set them up correctly and so you don't have to run migrations in the future. Broadly, there's 3 layers at which you can kind of subdivide your resources and use them to allocate and track costs. The first one is the account level. Most customers only have a single account, but you might have multiple accounts if you really want strong isolation between different lines of business within your company. If you're running in multiple regions or on multiple clouds, you will get entirely separate billing information for these different accounts, but you can, of course, join it together. But typically, we see most customers are running just a single account. Now, within the account, you can have multiple workspaces. Workspaces are another isolation boundary, but they're not quite as strong as accounts, right? So we find a lot of our customers will set up distinct workspaces for different levels, different stages of their CI/CD, right? So like if you have dev, test, staging, and prod workspace, you can kind of isolate your resources that way. Another way you can also subdivide your costs through workspace isolation is by assigning different teams to different workspaces. Inside of the workspace, you can actually also set up kind of organizational boundaries, right? So when you create resources like clusters or other types of compute, warehouses, other things like that, you can actually decide which users get access. So you might want to group your users based on, and create clusters for specific groups of users based on which cost centers they roll up to, which projects they are working on. This can kind of help you subdivide your costs and understand which project or which team is consuming how much. Now, these 2 different constructs, accounts and workspaces, they're managed by 2 different personas. The accounts are kind of managed by account administrators. These are super users within Databricks. They have broad privileges within the platform, and they get access to lots of billing information that isn't available to other users. So they can use tools like budgets to track and alert on spending. They can use our account usage dashboard in the account console. So this is a dashboard that actually helps you visualize your cost. We'll have an example of that in just a bit. And they can actually broadly define the roles and privileges other users have when it comes to how they can consume billing information, or if they're able to create resources that create spend within Databricks. Workspace administrators are one level down. They are admins for a single workspace. And so they govern access to that workspace for users. They can create things like cluster policies to kind of design guardrails for spending within a single workspace. And they can even manage compute creation for users in a workspace. So we'll just get to this in 1 second, actually. You can kind of see there's different ways that our customers tend to manage how users can use Databricks, right? So typically, this is kind of the progression that we see from our customers as they mature over time. So when you first start using Databricks, you might have just a small team of users with broad privileges within the platform. They can kind of do and create anything, spend an arbitrary amount. Maybe you're just trying to kick the tires on Databricks, understand what it's all about. And then as you kind of mature over time, you might add more and more users, right? But you don't want all of those users really to have broad privileges within Databricks. You don't want them to create an arbitrary amount of spend for you to manage. So what we typically see is the new users will be managed by some central platform team. So that central team will basically create and manage resources for those users and assign them to clusters that they've created for them. But they won't let them actually create compute within Databricks because that can, if they do it incorrectly, cost a lot of money. Eventually, though, we find a lot of our users or a lot of our customers will scale even beyond that point where having a central team administer all of your users, if it's hundreds or thousands of users, is no longer tenable. And in that case, we see that they will actually delegate responsibilities for managing cost to kind of more trusted users within their organization. These might be your senior data engineers, your DevOps engineers, or just team leads, right? And so a central platform team will basically delegate those responsibilities through tools like cluster policies. And so these trusted individuals can actually create compute, but subject to guardrails that are defined by your central admin team. So your account and workspace admins can create these policies which allow you to delegate access to creating compute to more trusted users, but you can kind of constrain them in terms of how much they can spend. And then those users can create compute for your users that you don't really trust to create clusters and warehouses. And give them access to those resources. Now, when you think about aggregating your costs, reporting on your costs, you're probably going to want to subdivide your costs. Like Sadhana mentioned, you don't want to get one big monolithic bill, right? You want to understand who is responsible for consuming what, whether it's a specific cost center, project, team, what have you. And so the way Databricks is designed to manage this is through tags. Now, what are tags? Tags are basically keys and values, just strings, that you can apply to nearly every resource within Databricks. And these tags, they basically will be propagated to your billing records, both on the Databricks side and on your cloud provider side. So what you can do is, after you get your billing records, now that you have these keys and values, you can aggregate your costs by those dimensions that you define. It can be any custom grouping that you'd like. So for example, if you want to see how much a particular project is spending, as long as all the resources in Databricks for that project are tagged so that they belong to that resource, that project, you'll actually be able to aggregate your costs after the fact and see exactly how much that project is costing you in Databricks. What you really want to avoid is that top bar there where nothing is tagged and you kind of just get one big bill and you can't tell where it's coming from. And so you can kind of see, right, we've already started exposing this tagging functionality across multiple interfaces in the product, and the expectation is that every product within Databricks will support tagging. And on top of that, you can also, as admins, enforce tagging so that your users don't have to input arbitrary tags. You can actually require them to supply tags and fix tags that they can supply through tools like cluster policies and budget policies for serverless. Great, so those are some organizational considerations, and now let's look at some technical considerations when it comes to thinking about how you manage your costs. So broadly, this is a very complex topic, and we won't get into all the details here, but the thing to keep in mind is obviously there's always a trade-off between price and performance. So you need to really think about what your business needs are when it comes to performance, and where you're willing to trade off better performance for price, or perhaps where you're willing to accept less performance for a cheaper cost. Now, the dimensions of performance that are important to keep in mind are things like How fault tolerant does your workload need to be? So for example, if you use spot versus on-demand instances, you're trading off fault tolerance for cost. Spot will be cheaper, but you might suffer spot evictions, which can kind of increase the length of the runtime of your workload. You need to consider throughput and concurrency. How many users are going to be using your DB SQL warehouse? You should think about what your SLAs are, your execution time for your workloads. How long should they run? How much compute do you want to throw at these workloads in order to run them faster? And then of course things like scalability, right? How many users are going to be executing workloads at the same time? And then how quickly do you want users to be able to start running their notebooks or executing their DB SQL queries? Let's look at a few examples of how these trade-offs work in practice. So in this first scenario here, you can imagine a company is basically going to see a big spike during the holiday period, and they know their business analysts are going to be running lots of DB SQL queries to kind of do some demand forecasting to help with supply chain analytics during the holiday season. So what will we need to consider when it comes to DB SQL in order to make sure that these users are set up for success? Broadly, there's two things, right? So if you think about what's going to happen is a lot more users are going to be running queries at the same time. And so when you think about DB SQL, that would mean you want to increase the concurrency that's supported in your warehouses or in your DB SQL endpoints. So there's a specific control that lets you scale the number of clusters created behind that endpoint that will let you basically increase the number of users, the amount of concurrency that you have available for any particular warehouse. On top of that, you can imagine during the holiday period when everyone's under time pressure, they might be frustrated to spend a lot of time waiting for their warehouse to come up. And so you might want to do something like switch your warehouse to a serverless DB SQL warehouse where the startup latency is very low. Alternatively, you could increase the auto termination threshold. So that way, when someone steps away for a coffee and then comes back, they don't lose all of their work and all their cache data because the warehouse was terminated. In the second example, you could imagine a company is working on an ETL pipeline and it has very strict SLAs, right? There's some downstream dependency. Maybe you're delivering data to a customer and you need to get it there within a certain amount of time, otherwise you'll be penalized. So what are some considerations there? Well, of course, fault tolerance and reliability. If you're suffering from reliability issues, you probably won't be able to deliver your data on time. And so that comes back to things like spot versus on-demand instances. We use spot by default to help you save costs. But if you have a really strict SLA, it might not make sense to use spot instances. You also want to think about execution time. So you want to size your cluster correctly or your warehouse correctly in order to actually be able to execute this workload quickly enough. Right? So if you have a really strict SLA, say 10 minutes, you might need to pick a larger size for your warehouse or for your cluster in order to execute your workload in time. And then lastly, you need to think about startup latency. Again, using 10 minutes as an example. If you need to complete a workload and ship data somewhere in 10 minutes and it takes you 8 minutes to run the workload, you can't spend 5 minutes starting up your cluster. And so you have lots of tools available there. So for example, you could switch to using serverless jobs instead of normal jobs. You can use an instance pool to accelerate the launches of your instances from dropping that from 5 minutes to 2 minutes. And so there are many knobs you can use for each of these to basically trade off the price that you're going to pay for the performance needs that you require based on your business requirements. Cool.
Thanks, Piyush. So we're on section 3 now. How do you actually operationalize some of what we put into practice? The customers that are most disciplined about cost management, we see them take sort of 3 approaches in terms of cadence on how often they're looking at their costs. On a weekly basis, you'll often have, especially in a more federated model, team leads, department heads do a weekly audit over overall spend trends. For example, am I seeing any anomalous spikes in my spend this past week? Has there been a significant growth rate in one product line versus another this week versus last? On a monthly basis, they may pull in more executives, overall management, their finance team to understand pacing. Maybe you've signed a commit with Databricks, maybe there are internal budget targets you're trying to hit. What is our actual pacing on spend against these targets? And then on a continuous basis, of course, you don't want to manually be checking on a weekly or monthly basis, but on a continuous basis, how can you be confident that you'll be alerted if anomalous spend is causing you to deviate from your budget target? There are 3 tools, and we'll get into detail on each one of these, that allow you to do this continuous weekly and monthly type review process. System billing tables is your gateway into granular and low latency cost data. We'll get into that in a second. On top of that, using the AI BI usage dashboard as a reporting interface to do that type of executive and operational cost review. And then on a continuous basis, relying on a tool like budgets to ensure that you will be alerted if the pacing against your budget is accelerated compared to where you expected it to be. So we'll start with that first one here. And this is just an example of the company. They're in the crypto space. They use exactly this model as well. Their executives look at the dashboard on a monthly basis, but because the volume of crypto data can be volatile, on a weekly basis, they have individuals checking their spend targets as well. Out of curiosity, by a show of hands, who's familiar with the system billing tables? It's a good portion, maybe 70% of the crowd. The way to think about cost observability is there are different sort of interfaces for it potentially. But perhaps you're looking at your Azure bill, GCP bill, AWS bill to get a high-level sense of how much you've spent on Databricks on a certain period of time. But if you want to get low latency, high granularity usage breakdown, that's where system billing tables will come into play. In general, system tables are delta tables that will give you a window into all of the operational activity across your platform. Billing tables is one specific instance or schema of those system tables. Okay, so what can you find in these system billing tables? If you click into it, there are a lot of useful fields here that will make your cost reporting easy and effective. For example, every spend dollar you can tie to a billing origin product. So you'll have a sense of which particular product lines that spend came from, and also which particular SKU if you're getting into a second level of detail. Also, what particular objects, billable objects, did the spend come from? Was there a particular warehouse, job ID, warehouse ID? As I mentioned, that information will be present in the usage metadata field. And then with identity metadata, this will actually allow you to attribute cost to the principal level, whether that's a user principal or a service principal that might be leveraged for sort of a kind of run submit job, for example. And then as Piyush mentioned, those tags that you apply through the UI, through an API, through a policy, those tags actually propagate down to the system billing tables as well. That way you can group cost based off your own business taxonomy. So what did we do? Last year, we built a AI BI usage dashboard on top of these system tables, and that's available in the account console today. Is this something folks are familiar with by a show of hands? Great, it's a good number. So this is available today in the account console. You can import a dashboard, spread it as widely as you want within your organization. We have some customers that actually make the dashboard accessible to all users in their workspace because they want everyone to be empowered to see the costs that they generate. The dashboard will give you a high-level overview of overall usage. Again, for a monthly or weekly cadence, this might suffice. If you're looking to do chargebacks, how do you actually tie those costs based off a tag key value pair? And if you're just looking to understand what are the top drivers for an optimization exercise, the dashboard will give you that lens as well. But what we've heard for you is that you all want more than just a high-level reporting interface, of course. So we've spoken with a lot of you who've used the version 1 of the dashboard, and we're excited to be introducing Usage Dashboard 2.0 post-summit as well. What this is on the same system table, but also pulling in other system tables that have been newly released as well. This is a more powerful and actionable dashboard that lets you do key tasks like chargebacks and showbacks, tagging compliance, and down to the level of organizational accountability. Who are the actual individuals I need to nudge to optimize their cost? This is a quick preview of the usage dashboard. You'll see forecast capabilities are available through the AI forecast SQL function, an ability to break down your cost by product, an ability to rank your costs by top objects. This is a little fast, but these slides will be available. Here I'm using budget as a primary tag, and I'm looking to filter my costs by the budget tag. You'll see a large portion is untagged, but when I click into what is tagged, I now can actually charge back against, for example, the OpEx and runtime budget key. And if I actually want to drill into what particular objects have this budget tag or are missing it, I can actually use this top objects tab to drill down to the specific object ID. Here I'm actually identifying a couple of objects, who owns them, and I can click into a SQL warehouse from that interface and pull up the particular warehouse as well. We'll have more resources available on the dashboard 2.0, but in a second we'll show you a survey. If you're interested in getting a preview of this view, let us know and we'd be happy to share it. On top of the usage dashboard, for a more continuous, asynchronous monitoring experience, last year we launched budgets. This is again available in the account console. What this allows you to do is to create a budget either at the account level, workspace level, or on a combination of tags. Define a particular budget number, perhaps this is your commit divided by 12, for example. Share that out with a couple of individuals, and then you can be confident that you will receive an alert via email if you've actually surpassed that budget. Again, we've talked with many of you who have used this tool, and we're excited to announce a couple of enhancements coming to the budget tool, where you'll see richer visualization to allow you to more quickly identify the particular spend drivers, more configurable thresholds so you can get earlier alerts if that's what you desire, and an improved tag search experience so you have an easier time parsing through all the tags in your system and understanding what to apply a budget on. We'll leave you with best practice number 6 here. We've talked about performance, we've talked about cost, but there's a third dimension that is historically harder to try to wrap your hands around on any data platform, Databricks and beyond. This is how do you actually measure the business value of the assets that you're creating? As an admin, you should be constantly asking yourself, are these dashboards that I've built up and are refreshing on a daily basis, are they actually powering critical business insights? Are these jobs that are also running on a frequent basis, are they automating manual processes that save us a lot of time and effort? And finally, are these AI experiments, the model serving endpoints that I know my data scientists have provisioned, are they running useful POCs that we believe will eventually make its way into production at some point? How do you get answers to these questions? Well, we're working on a number of tables and logs that allow you to get those types of insights. For example, using the audit logs, there's a system access audit table, you can actually answer questions like, how often was this Genie space updated? Or how often was this notebook accessed as well? These are event logs that are available for numerous services that give you that sense of utilization. Using the query history table, you can actually understand what are the number of unique users that have executed a query by interacting with the dashboard. Are there actually a lot of users interacting with this dashboard in the first place? Data lineage, which is a very special feature of UC, will give you a sense of lineage between jobs and tables. Is this job that's running on a daily basis? Are the downstream tables to this job actually also high value? And just as another example, for model serving endpoints, which again are typically provisioned or paper token, what is the actual payload of requests against this endpoint? These are all types of questions that you can answer using some of the resources on the right-hand side, and that allows you to scratch this final surface of what is the actual value and ROI I'm getting out of my Databricks activity. So with that, we conclude. Before we wrap up, we would actually love to take a couple of seconds of your time and have you snap out your phone, take a sort of picture of this QR code. What you'll find here is actually a sense of where we're investing our roadmap in on cost management, and we would love for you to vote and help us identify what we do next. So I'll leave this on for a couple of seconds to ensure that you get those surveys loaded. And beyond that, here's a recap of the best practices, but because this is a foundational session, we want to ensure that we have time for Q&A. So we will actually transition over to that now.